Now, recapping what we learned last time were two basic facts. In one case, we looked at an infinite wire, and in this case, I'm drawing it as though the wire were coming straight out at us with the current flowing toward us. We learned then that the magnetic field lines that we get by drawing tangent curves, which are tangent to the field vectors, that in that case, the magnetic field lines are actually circles, which circulate around, centered on the wire. We learned also that they circulate around in the sense given by right-hand rule number 2. So that, for instance, in this case, if you align your thumb with the current, which is coming directly out of the page, and look at the direction around which your fingers naturally curl, they curl around precisely in the same direction as these field lines. That observation allowed us to posit an equivalent fluid model for the magnetic field case. In this case, the idea is that you take your wires that make up whatever your circuit is that is carrying the currents, you immerse those wires in fluid. So here's a tank of liquid. I've indicated it here, that's a liquid. And in this case, I actually have two wires, one coming straight out towards us and one carrying a current here off to the right in this particular case. And what you do is you immerse those wires in that fluid, the same wire geometry as the wires which are carrying your currents, and then you set those wires to rotating in the fluid according to the direction given by right-hand rule number 2. And there's a magic formula for the rotation rate. The angular velocity omega should follow the formula that I give to you here, where r is the radius of the actual mechanical wire that you're using in your fluid model. And then you can show that under those cases, the wire will begin to drag the fluid around. It will then create exactly the same circulating patterns, creating what is known as a vortex flow pattern. In fact, it turns out that the Biot-Savart law was first written down. Biot-Savart were not studying magnetic fields. They weren't known yet in this form at that time. They were actually studying fluid mechanics. So this law that we've been writing down actually comes to us directly from fluid mechanics. In any event, that is the equivalent fluid model.